Hello everyone, my name is Stefan Lapadat and I applied for a position in your team. On that occasion, I was assigned with a task to create a simple, well, maybe not that simple application, which will, which should translate from one language to another. I created 2 pages. One of them is the one that you can now see. The purpose of that page is to enable user to input a certain word in English or in Spanish language, because I've used the web service, Merriam-Webster web service, which offers translation from Spanish to English for free. My application then supports only translation from Spanish to English and vice versa. So let us see how it actually works. We can input a word and the program will output the translation. So for example, example. This is the output. This is the Spanish. I don't know how to pronounce this, but this is the output for the word example. Let us see further. For example, apple, manzana. Okay. Or elephant. So as you can see, the translation tool actually works, and with any word that is in the Merriam-Webster's web service or in that dictionary, we will get an output in Spanish. Now, how I did this? Well, the front-end application is built using single page application technique, let's say it like that, in React. Backend part of application is built in ASP.NET Core MVC. I'm not completely sure, but the requirement of the task was perhaps to make backend web service in .NET framework. But since I installed on my computer Linux, and Linux does not support .NET framework, I wasn't able to create my application in .NET framework, at least. So that's why I created it in .NET Core. I believe that it wouldn't be such a hard thing to make changes in my application in order for it to work on, for example, ASP.NET Web API framework. So let us see where is this web service. All right. Before I started recording, I've started both front-end and back-end applications, and they're both started locally. So as you can see, front-end is started on localhost port 3000, and web service is started also on localhost but 5000. So let us see it in practice. Translate. Okay, Apple. So basically, this is the response of the Merriam-Webster's web service that I just pass on to the front end. The most important thing in response of this web service is this short definition. Now this is a bit strange, because as I can recall, Apple was generating a different response, manzana. And why is this so? Manzana, okay, short definition. Yes, this is okay. Yes, and basically this is what I show to the user. They are returning array of different, let's say, different entries for the same word, because apparently Apple can mean different things in English language. So never mind. On this URL you can find my web service. If you were in front of my laptop, I wasn't able to publish this web service to Azure or Amazon or some public site, but I actually was able to publish my React application, my front-end application, and you can see that it is actually on this URL, awesomtranslator.azurewebsites.net. But unfortunately I tried, but Azure wouldn't let me upload or publish my backend web service to their site. So that's why perhaps that is the reason why I am creating this video, to show in some semi-live manner how this whole system works. So there is not a lot of things to show in this application. I could now show the source code of both front ends and back end, but I'm not actually sure that was required. What could I also say? Well, I can't say I could talk about the things that I didn't actually manage to create. So one of the requirements of the task was this is what I suppose that it was a requirement, but I'm not actually all that sure. But okay, one of the requirements was to build a web service in .NET rather than in ASP.NET Core. This I failed to do. Second requirement was to translate whole sentences. Although this wasn't a requirement explicitly, since the task states that the actual translation of the input is not all that important, but still I believe that it would be better if I managed somehow to implement translation of the whole sentences rather than of the single words, even if it means that I don't translate sentences for real, let's say that, but that I translate them from some predefined set of mappings, let's say like that. But I started with this Merriam-Webster web service, and later on it was too late, let's say like that, to switch to a different approach. There wasn't enough time. So to translate whole sentences rather than just words. Okay, the third requirement was to that I didn't fulfill was to create backend cache. To create backend cache of already translated words. Alright, I'm sorry. Uma secund. I'm sorry because of that. There apparently is not a way to turn off this Skype. So to create I was supposed to create a backend cache of already translated sentences. Well, this seemed like a fairly simple task to do, and it is, but the problem is that I spent, for example, from my 2 days, I spent a day and a half perhaps on learning how to create single page applications, because that wasn't my, let's say, default approach to creating applications, and this was my first time with single page applications. So I've spent a lot of time working on front end, and thought I will still have enough time to create backend appropriately, but that in the end it wasn't the case. So I've just created a web service, but and it has some basic structure for caching, but that caching is not implemented. So that's the third thing. Let me see. Yes, I did not deploy my application to Azure. Did not deploy application to Azure or Amazon. That is also that would also be nice if I've done so. So in order for you to be able to test my application appropriately. Let me see. Okay, we could go through the source code a little bit. Well, okay, this is backend. Let me check the front end first. So front end, basically, front end is, as I've said, a React app. It is hosted on Node server on Azure, and the most important things are in these two folders. Node modules and build are things that are not all that important for now. That is basically a library of my application. And build is build is output of a build process. So let me go through files. Well, as in every single page application, we have a single HTML entry, In this case, this is I've put it in a public folder and it's called index.html. It is very simple, as you can see, and there is no need for us to elaborate more on it. Then we have index.js file, which is entry point for JavaScript, actually. What it does, this is a class from React DOM library, which is used to render React components in DOM elements. So it's also fairly simple. It will generate main component. We can see that component. We will see it later on in main.js file in components folder. And index.css is a file with our simple CSS for application. So the two most important and let's say biggest parts of this front-end application are two folders: components and services. Components folder contains, well, as the name says, components of an application. So basically corresponds to pages of our application. Services folder contains classes. So yes, if I haven't mentioned, but I've used ECMAScript 2016 classes in my solution almost exclusively. So that needs to be transpiled later on, which it always is done. So services folder represents classes which should provide pages with data. We have, but let's go to main.js, and when we go through main.js, these services will have more sense, will make more sense. Okay, we have main component, and right in the beginning we have a declaration or definition of translation service. Now here it says that we should use dependency injection. I'm not all that sure about how dependency injection works in JavaScript, but I know that it can be done. So in order to not have expressions like this, we would use actually dependency injection, and it would make our life somewhat easier. Maybe we could test, for example, this application better or something like that. So what do we have here? We have instantiation of remote translation service with cache. And what that means? That means that we will create an object which will work in such manner that it will only call web service methods if it doesn't have already translation of a particular input in its cache. This class has a constructor with two parameters. One is the instance of remote translation service class. That is translation service which is used to actually call a web service. The other parameter is local translation service. Now, local translation service can also be implemented in different ways, and I have done that, and that is part that you see here in cache folder. But we'll come to that later. So we have these two things, and we have somewhat complicated method which is used to actually translate our input. So how does it work? Well, it works by first checking whether a particular input is already in the cache, and how it's done by calling local translation service .translate. And then this is complicated part. It's not complicated, but actually I wasn't using async await in JavaScript. I'm not all that sure. I haven't had the time to check whether I can use in this configuration of Node and the whole my platform, could I actually use a feature of JavaScript which is called async await. Because I'm not using it, then I have this, let's say, a problem with JavaScript promises. That it is completely not readable. But basically what it does is that it that after local translation service returns us a result, we check whether that result is null, and if it's not null, we will return that result, and if it's not null, if it is null, then we will call remote translation service to translate our input, and when that is done, we will store result of so B, we will store that result in our local translation service, so we will catch it to be able to use it on later occasions. So that's basically our remote translation service with cache, and it is built with a certain flexibility because, for example, there is a requirement in the task to call web service method to translate input 3 seconds after user stops with typing. And for example, I don't have that part implemented explicitly in the code, but I have a more general feature which is this feature that I explained, and this more general feature can be used to implement the feature that I said. So basically, if a user starts typing and he stops for a 3 second, we will call with remote translation service with cache, we will call web service, get the result, and then store it in our local service. After when a user clicks OK, we will again call a remote translation service with cache to translate our input, but then we will have a cache hit and not a miss, so we will not call web service again. Why I say that I have implemented somewhat more general abstraction than what was requested in the task. That's because with this part, which is called cache, I can control, for example, where I will store this translated input. So, for example, I have an implementation which is called in-memory storage. So that cache will be refreshed when a user refreshes a page or closes a browser or something like that. The other implementation is called browser local storage, and that is, let's say, more durable implementation of a cache. So if we, for example, want to free our server from calls from clients that aren't really necessary, we can use browser's local storage to have some more durable cache. I'm not actually sure whether in an application like this we would have a lot of cache hits, but who knows? Maybe we would be able to free our server a little bit. So okay, let's see how local translation service works. Local translation service takes one parameter, cache, which is called cache, and it stores it in its own private, so not private, but it's in its own field, because in JavaScript we don't have concepts of private and public and stuff like that, but it kind of resembles those access modifiers from Java and C# and C++. It also has, so because this local translation service is also a translation service, this is another thing that we cannot implement very well in JavaScript. It would be nice if we could, for example, say here that it implements translation service interface, for example. And TypeScript is a very nice language, in my opinion, which allows us to do things like that and to get compile time help from a compiler. But never mind. Okay, we can do it also like this. We have a translate async function which takes input, and how it works. It first checks its own cache whether it has a value input. If and cache result returns us array. If that array has something in it, then we return cache result. So we return the first, and it will be actually the only item in this in this array. Otherwise, we return null. And since this isn't actually all that async method, but in order to let's say be consistent with remote translation service, I've implemented it in such a way that that we return promise from this translate async function, and it wouldn't be very smart to call it translate async at all if it wouldn't return a promise. And the third method is store, which is used when we have a cache miss and then call call a web service, and afterwards, when we receive result, we want to store received item in our cache. So on this level, we still don't know what is cache, and that's where we go to cache folder. Cache folder has three classes. One of them is local cache. That would be well, we could say that it would be sort of like a base class for the other two, but it actually is not, because I'm not using inheritance here, but rather composition. So local cache takes a parameter of which represents the actual physical storage, and what does it do? Well, it implements one rather naive approach at caching, but in such a constrained time I couldn't come up with something better than this. So it has a method insert, because it is cache, so we want to insert stuff in it. Insert item, and how does it do? Because storage has a property called capacity, but that is not actually important on this level, but it can be full. So if our storage is full, then we will basically swap a random item from a cache. So that is the part where I said it wasn't the best. We should have some sort of better algorithm of swapping in a cache if we want to have better performance of our cache. So basically that's it. We inserted a random index. Otherwise, we just insert as a last item in a cache. And of course, we have a method which is called getValue. It is since cache is key value store. This method serves the purpose to return a value for a certain key. And finally, at the lowest level, we have storage, in-memory storage, and browser's local storage implementation of a storage which is used in cache, which is used in local translation service. So in-memory storage basically has a constructor with capacity parameter, and it has it instantiates a queue, which shouldn't actually be called queue in memory storage. Well, it's not a queue. It's basically just a set. It's not a queue. But okay, I've called it a queue for some reason. So it has a method insert at certain index and certain item, insert last, and its method full tells us whether it is full or there is still some place left in it. It has also a method all, which is used by local cache. Actually, I think that I've put it in there. Well, yes, in getValue method. There is a call to a method all in order to see whether actually whether actually we have a certain key in our cache. So okay, maybe this get value shouldn't be implemented here on this level, because particular storages could, and that is definitely the case, so this should be moved, because particular storages could implement their own search functions in a more performant way than this. This is not good if a particular storage can implement it better. This works in linear time, and for example, as I know, there is a index DB interface on browsers, so that is a certain kind of a database on browser level. So that implementation of a storage, I didn't create it here, but that implementation could actually be more performant than this. So this function should be moved on lower level. But okay, I've done it like this for now. This is in-memory storage, which just uses an in-memory array, and browser's local storage. Well, browser's local storage uses local storage API, and it works in a similar fashion as with array. There is a certain complication with storing, because local storage is again a collection of key value pairs, but they are strings, so we need to constantly stringify and parse objects that we want to put inside of our local storage. But okay, pretty easy, nothing all that complicated. So this is the whole services folder, and now let us see actually how this whole thing is reflected in here. So okay, this is just a key for a local storage. It's nothing important, but this is perhaps important, and I will demonstrate in a browser how this thing that I just explained, how it works. So let us change this thing for a little bit. So okay, let's put a capacity. This is a capacity of our and we say that we use browser local storage in here. So let us see how this is reflected in browser. So when I save this, files should be recompiled, and we should come here on our input page. So let's say, let's see local storage. Okay, get item, and I have already this. Alright, we have something in here, but we will now empty our cache. Okay. So let's see how a program behaves when with empty cache. So first of all, we elephant. I'm not using elephant because I've hard coded it somewhere back, but that is just the first thing that comes in my mind. So what do we see? We see that after 3 seconds there was a call to web service. Okay. And if we go to continue, there is no call to web service. Okay. Now go back. We will now delete this, and when we enter it As you can see, there was no call. You can see in the right part of the screen there was no call to web service when I deleted everything, because it makes no sense to create to call web service for an empty string. So let's do this, and again we will see that there will be no call. Why? Because we have this elephant translated in the cache, as funny as it sounds. So local storage get item translation. Now you see we have it in our cache, and this local storage will be used by our local translation service to give us the result when we click continue. So okay, let us input another word, banana. Okay, your final translation is okay. Again, we've inserted banana in a cache. Alright, let us now insert, for example, lemon. Okay, this is the lemon, and we now have a bug in here. And why is that so? Well, that is so because I have inserted lemon and then waited for 3 seconds. The call to a web service was made, and then I clicked continue, while the response from the web service was not from the first response was has not arrived yet. And so basically I have created two entries in my cache for the same thing. So whether this will create some nasty problems later, that is now unknown, but definitely something which should be fixed. But never mind. Or mind. Okay, let us now create wolf. Okay, key lemon, key wolf. We can see that capacity of 2 is reflected in replacing one random lemon from local storage and replacing it with wolf. So basically that's it. I could perhaps change this thing for an in-memory storage, or better do it like this. I could switch to in-memory storage with only a capacity of only 1, and in that way effectively to get what was required in the task. So let us see, I didn't want that. Alright, never mind. Okay, so I believe that for local storage now, okay, it has 2 entries, but we will clear it just to be sure that it is not used right now. Okay, so let's see on the network tab, wolf again. 3 seconds have passed and we have sent a new request. Alright, let us see what is in the local storage. Alright, it's null. There isn't actually under this key. But if we check the network tab and now click OK, we will have our response, but this response does not come from the web service, it comes from the in-memory cache. And that is basically a, let's say, demonstration of a strategy pattern applied to JavaScript, because there is no reason why strategy pattern couldn't be applied to any language. This is basically polymorphism in action. So that's it. What do we have here? Since now I don't actually know whether you that are looking this video are whether you know React or don't. I will not go too roughly through all of those components, but just briefly. So since we have a single page application, we need to, so not we, but rather a library, in this case React library, routes actually different URLs to different JavaScript segments. So this is a routing section of our application. This function is event handler for handling input change, and in this area we can see classic clear timeout and set timeout, which are controlling the timeout, which are using timeout period in order to control when we actually send requests. So it's nothing complicated, 60 lines of code in this component. Translation input represents, this is a file that represents this page. So this page. Okay, there is some CSS here, but it is in index.css. Okay, translation input, translation output. Translation output is a bit, let's say, a bit more complicated than translation input. And what is the complication? Well, it is tied to let's say that asynchronous nature of JavaScript calls to remote endpoints, let's say it like that. So first we need to, because the components are actually rendered synchronously, but calls are asynchronous, so we have to check a few things here in order to not to basically to wait, to implement waiting of our response. So for example, now I'm just bragging that I know this word. All right, but okay, continue. We will have a result immediately, but if I'm a little bit faster, for example, like this, you see the delay. So component was rendered while the response was not yet received, and only afterwards we did present user with complete response. I'm not actually sure, since, as I've said earlier, I have not used React in a single page application manner yet. This is the first time, so I'm not all that sure whether you could somehow mimic the classical page rendering, where for example if a user clicks on a link, he will wait for a complete page to render, provided that the page is not using Ajax or asynchronous calls on its startup or something like that. So that would be it, and we have another file which is called error, and it basically it says user that there was some sort of an error with any part of an application. So that's it as far as front end is okay. Here you can see that this application is, well, perhaps we could demonstrate this error. Alright, so translate, let's say continue. Error, we're sorry, something went wrong. This is the error view. And why is there an error? Well, because this application, which is hosted on Azure, cannot access its web service. All right. For the backend part, this is somewhat illogical, let's say, but I have a bit less code for backend than for front end, but that's just how it is. So as I've said, I've implemented it in ASP.NET Core, and ASP.NET Core actually doesn't have separated MVC and web API frameworks as ASP.NET has. So there is only one framework, and it's called ASP.NET MVC, and it is used both for creating server-side rendered let's say graphical user interfaces, and for creating web services. Important parts, so APIs are actually put in a folder with controllers, and we can come here to see what is happening here. So I have one class. It's called translate controller. This translate controller has a constructor with 3 parameters. These parameters are injected through the default ASP.NET Core dependency injection mechanism. So basically that's it. I have here. So this is that not implemented cache. So I have a base abstract class cache, which is generic. These values represent, so these type parameters represent key and value, and this is the default implementation file cache. I decided to go on a route with files because I was actually optimistic of deploying an application to Azure, but I thought it would be easier to deploy it using if it uses files rather than database. I saw that as a complication in deployment process, so I decided to go with the files. So this is a dependency injection for cache. Dependency injection for configuration is not done explicitly by user, but rather than by a framework. And we have for configuration for for HTTP client. So I use one instance of HTTP clients, HTTP client for all users, since this class is thread safe and there is no reason why we should create different instances all the time. So, alright, that's it. Now this should be deleted. Okay, this was something from the testing. And here we have actually a method or an endpoint which routes are base of our application, base URL of the application, so which is domain on which it is hosted, and then this controller is represented by translate path, and this method is represented by well, whatever user types in. This is how is that called? Variable path parameter, something like that. And how it works? It works by first checking in cache whether it can find a particular translation of input, and how it works. I said that I didn't implement that. Where are my models? Here. File cache. Okay, file cache implements or extends this base class, and it just returns null. So this is to be implemented. It's not functioning. It's not functional. Okay, so string result is null. Basically, this serialized object is null. If string result is null, so if we have a cache miss, we call the Merriam-Webster web service. HTTP client get async URL is a helper method to provide us the URL for this particular input. Key is get from from the configuration file. So key is from the configuration file. Okay. Result will be what we get through the remote response, and we read the contents as a string, and then we store that in a cache, in our cache. So basically the same logic as what I already explained in the front end. But you can see here how there is no problem with tasks, as there is a problem with promises in JavaScript, since I'm using await and async in JavaScript. Store okay in cache, and then irrelevant of whether we have found item in cache or we have called our web service, we will deserialize this string and return that object to a client. I didn't, well, is it fair to say have a time, or whether I was too slow, I don't know, but I didn't do the classical process of creating the so-called DTOs for result from the web service, or from for the result that is sent to front end. So basically, this is a somewhat crude implementation of a web service, but to some point functioning one. So basically that is it. There is no authentication in this application. It was not required, and this is basically the XML file that would be used for implementation of a cache. File path is this is a key for our Miriam web service, and this is file path for our file. Of course, this is not a complete. This is only a relative to a directory of our web service, to our base directory of web service. If I'm not mistaken, I have said everything that I did not implement. I tried my best to explain what I did do, and I have demonstrated functioning of a complete application. So again, yogurt, let's say. Interesting. No translation for yogurt. Maybe I didn't write that. Maybe that's not how it's said. Okay. Or for example, animal. So, okay, this works. Well, that's it. Here we will finish our journey through awesome translator, and that's it. Bye bye.